really happy to be here. Let me start this presentation with a quote. AI has changed the way I work, from a famous anonymous programmer 2025. And I think many of us can relate in the room. Like we've seen Raphael's talk, we've seen Christophe's demonstration earlier. I relate a lot. AI has changed my work. No, it literally changed my work. I changed job to join an AI company. And not just any AI company, the European leader in large language model creation, Mistral AI. Woo! If you don't already know who Mistral AI is, they published their first models back in 2023. Like, literally published, they open sourced them. Then they started to sign partnerships with institutions and companies to bring AI to solve real-life business problems at scale, along continuing developing new models, of course. And then last year, in 2024, they launched their first B2C tool called Le Chat, which is a conversational tool on web to allow anyone to interact with Mistral models. Le Chat means the cat in French. So the new logo is like a cat's head with a little mustache like this. Le Chat grew and grew, like code generation, image analysis, document libraries. Only one thing was missing: an app, a beautiful app to actually put Mistral models into everyone's pocket. And this is when I joined them last year to build it with them and with React Native and Expo, obviously. We launched it in February 2025. And only 8 days after the first release in production, we had already reached more than 1 million downloads on iOS and Android. So this was great. This was like a great moment to live as a developer, and it's still a great joy and pride to work in this team and company. But maybe it's time to introduce myself a little more. My name is Delphine Bugner. I work in the engineering team of Mistral AI. You may have seen my drawings online. I like to do them for the React Native community. You may also have seen my yoga talk last year at App.js. And if you have seen this one, you know that what I love most of all is to look under the hood of the technologies I use and actually understand how they work. And today, the technology we're going to looking into is the streaming of text, because it's an essential building block of any generative AI application. Let me show you. When you prompt Le Chat with a very pertinent question, his answer does not appear into a single block of text after an eternal loader. It appears word by word on screen, exactly mirroring how generative AI works. Generative AI creates the answer token per token, so it's of crucial importance that we reflect these changes as soon as they arrive to the user to ensure like stream experience. This is a stream request, but it's not that obvious to do in React Native. And I learned that the hard way. When I first joined Mistral, they already had an internal version of the app. My first mission was to integrate it inside the monorepo and start to share some code with the web. The first time I tested my newly PNPM proto, roughly this happened. An eternal loader. Generative app, not generating anything. That was a really lonely moment. The answer of what was happening was actually written in my notebook when I first analyzed the code base when I arrived. A polyfill were used to stream. You probably all know what a polyfill is. It's when you replace a method that is available globally by your own custom implementation, maybe because you can't rely on the same primitives as what the global method used. You need to put them in your index.ts file, and I simply forgot to move this file when I moved everything inside the monorepo. In our case, this was a fetch function that was polyfilled. So as soon as I put it back in the index.ts file, streaming started to work again. But it was too late. I'm a stubborn person. I wanted to know more. Why was a polyfill needed to have streaming working in React Native? Why was it not included by default? And what is a stream request compared to a normal anyway? And what's the difference between web and mobile? This is what we are going to see now. This is a brief history of streaming. And when I mean history, I really mean going back to the very first time the concept was defined, because streaming is old. Mathematically, streaming just means an exchange of data between a source and a target that is continuous and potentially infinite, where you don't know in advance which size it will take. It's as old as the 50s in Fortran, where the source was a keyboard and the target was a monitor. The goal was just to display the characters the user was typing. Then in the 70s, Linux formalized the concept a little more with the notion of standard inputs, standard outputs, and a false signal. It was used to read files or write some stuff on the disk. And we need to wait the 90s to have streaming over the wire with HTTP 1.1 and trunk transfer protocol. We could already stream HTML at the time. Then in 2006, the Opera Navigator developed the server-sent events API on top of trunk transfer protocol. That was like easier to write. You can identify it with this text event stream header, and this is exactly what we use on the server at Mistral, like many other LLM applications. And then on the client, we use the fetch function that was introduced in 2015. Why 2015? It's also the year of the publication of ES5 that introduced the concept of promises, and fetch is based on the JavaScript promises. It replaces the old XML HTTP request API. Now that we have this overview, let's dive in the fetch function on the client and look at the request. We're all familiar with this API. You fetch an URL, you await until you get a response. But the second part was always a little bit harder for me to understand. You also need to await to get the actual data by calling this .json or .text method. Why await? Again, I already awaited the line before. Could I just get like the response.body and get the data? And the answer is the response.body object is actually a very specific object called a readable stream. The .json method is just syntactic sugar on top of something more complex that involves streams all the time. It was streaming all along. Who knew this? And we're going to detail this immediately. When you prompt the server from your app, what you get through the fetch API is the status of the response and the response body, the famous readable stream. You can then, it comes with a default reader that you can plug to it, and you can then await as many times as the server is going to send chunk of data asynchronously, n times. Therefore, the name of async iterables. The data that comes from the server is like integer arrays, like this. So you also need to plug a decoder in the output of your reader to actually transform this into human-readable characters, like this. And finally, refreshing your UI and display the text as soon as it's arrived to the user, word by word, or should I say, token per token. As soon as your server sends you a chunk with an undefined value, this is the EOF signal. It means the stream is over, completion is made, you can stop looping in your stream. It's the same if the user wants to stop it. If you attach what is called an abort controller to the request, it will send a signal to the server and also block the stream. So if we have a look at an example of all the chunks we received, if you forgot to plug your decoder, this is how it looks like. This is how it looks once you decoded them. You might notice like the recurring series of numbers is just the way that we just signed our text chunk at Mistral with a 0, but like tool course chunks are indexed at number 5. If your server sends a single chunk of data, basically, you will just loop with your reader around a list of one element and decode it for your user. And this is what the .json or .text method does. So it seems pretty simple. Therefore, what was wrong? Why nothing was appearing when I forgot to add the polyfill in React Native? Well, in React Native, with the default fetch function, there is no response.body field. There is no response.body, no readable stream, nothing. Why, React Native? Why? The cat is not happy. And we are going to look into it right now. You might have already heard this. React Native is native. Literally. You call JavaScript function, but under the hood, somewhere, it has to be linked to native APIs. So if we take a look in the React Native core repository, like the fetch function, how is it defined? Is just exporting a single existing polyfill called the whatwg fetch polyfill. Whatwg, quite hard to pronounce. It's just a reflection group, like the ECMAScript is for JavaScript, but that thinks about what standard put in the browsers, especially standards to ensure compatibility between old browsers and new browsers. They defined a polyfill, replacing the fetch function by the API that existed before. Remember the chronology we saw? It replaces the fetch with the XHR equivalent, the API that existed before. Then the React Native team rewrote its own XHR version in JavaScript that is directly connected to the native, and this is a module called RCT networking in React Native that is itself connected to native API, finally, NS session in iOS, OK HTTP on Android. Phew, I'm stop with the name dropping. So where in this flow, where did the response.body disappear? Like, is it in the native side? Does native APIs do not support streaming? So I've been looking to the documentation, and they very do support streaming. It's even the same verbatim on Android. It's a response body. So they are not. Now, the bottleneck comes much earlier in the flow. As soon as the whatwg fetch polyfill, we already lose the response.body field. Remember what I said, whatwg ensure compatibilities between old and new browsers. Old browsers can't use readable stream anyway, so you don't need to provide one for them, therefore the absence of body. But what this polyfill provides is a direct replacement for the JSON and text methods not based on readable stream anymore, and this is why we can use them in React Native. Okay, but could we just jump over this XRChair polyfill blocker, like actually going to connect the JavaScript with the native without this polyfill? And this is what does the polyfill that we use, which is like the React Native community fetch polyfill. The first step to build this polyfill was actually this pull request on React Native 61 to enable external APIs to access the networking module of React Native. Obviously, they've done this because they were not happy with the way XRChair was doing streaming. Then it basically works with a system of events between the JavaScript and the native, rebuilding a readable stream on the JavaScript side based on the event emitted by the native module. So if we take the same scheme as earlier and rebuild it in React Native, this is how it looks like. We have the server emitting a chunk of data in binary. The native module emits an event, did receive network incremental data. The fetch polyfill acts like a proxy, catches it. It has rebuilt a stream on its own, and it enqueues the data in this new stream and exposes it to the front part of the fetch. And then we can continue the flow that we had seen earlier. Pretty straightforward to understand. But when I looked into what was into the native module, to look at the events that were sent to the JavaScript, this is what I saw. I don't know if you see very well, but we don't send binary data. We send a string. The text was decoded by the native module and converted to a single string, accumulated all the chunks that were sent by the server. So if we want to be accurate in our scheme, RCT networking decodes the text, sends a full string concatenating all the binary chunks, and then the fetch polyfill re-encode them to mimic the actual behavior of the fetch function on browsers and send it, and we redecode it later. So this is bad. The cat is still not really happy about this. And to understand why it was done like this, we just need to remember that the networking module of React Native was fully designed to work with React Native XRChair. The way of concatenating chunks into a single string is the way of doing streaming with XRChair. It's called the response text API, and it's not really performant. And if you're asking why React Native was built on top of XRChair and not Fetch and beautiful APIs, remember again the chronology we saw earlier. React Native was open source for the first time in 2015, the very same year as the Fetch was created. So obviously React Native had to be built on something older, and the standard at the time was XRChair. But we really do want to do streaming in a more performant way. So is there a possibility that we could read directly into the native API? We saw it supports streaming. Someone has done it. This is the good news. Someone has done it. It was already mentioned earlier today on this very stage, but I don't think he's here. This is Kudo of Expo. Woo! Really, he's done an amazing job. This summer, he just decided to publish two pull requests together, one for iOS, one for Android, rebuilding the fetch function from scratch, directly connected to the native API, and published it under the name of Expo Fetch. And yeah, I've checked. So it's based on the WinterCG standard. WinterCG, the concurrent reflection group that does not care about interoperability between browsers, but rather interoperability of JavaScript between all platforms, especially for mobile. So it's really like a good, better standards to follow. It also communicates with events between the JavaScript and the network. Expo fetch, between the JavaScript and the native, sorry, with the new Expo fetch module. And I have checked in Xcode, because I love putting breakpoints in Xcode. When we send the event from the native, we send binary data, no string decoded anymore. So this is roughly our head right now. We're really happy with this new API. And this was roughly my reaction when I understood what Expo Fetch was doing under the hood. Like, literally, I stopped doing my slides and opened a pull request on the Mistral repository to replace the polyfill we were using by Expo Fetch. And I'm very happy to say it's been 2 weeks since it's in production and since working perfectly well. OK, we are approaching the end of the talk already. I just want to quote 3 last elements around the streaming. The first of them is, even if we're now using the Expo Fetch standard that is so great, the completion request is still kind of its own in our repository because we can't use 10-stack query on it. 10-stack query is used everywhere in our code base except for the stream request because 10-stack query does not support streaming, but Dominic Dorfmeister is working on it, and the new API is going to look great. You're going to just have like 2 status success once you receive the status of the response, and the fetch status that will be updated when you receive the chunks one by one. So can't wait to use it, can't wait to use a new API for streaming. Second stuff I want to mention, kind of the elephant in the room when you're speaking about streaming, it's server components. You actually don't need streaming to have server components. You can render your HTML, your JSX on the server and send everything in one time to your front. But obviously, it's better if you can send it chunk by chunk and unsuspense or boundary per boundary your React app. And obviously, the final element I want to mention is React Native server component and streaming, because we have all seen this amazing talk by Evan last year at React Conf and App.js. Not only he has demonstrated and given a glimpse to us to what does the chunk of text looks like, not only for text, but for React Native components, he has also demonstrated everything that it can bring to an AI app. So I think it's also the future for Lusha. We will stream text, but we will also stream components. Remember what I said, it's really important to give immediate feedback to the user. And AI is going to be more clever and more clever, able to do new things. Like, if I just take the new agents API that Mistral published last week, your agent is going to walk around and do things in literally a lot of different places. So if you can give visual feedbacks to the user or the process of reflection of the agents, it will just like make the experience more fluid and more trustful for the end user. The future is bright for React Native. The future is bright for streaming and AI. So thanks you for all, and use the Lusha of Mistral.